Hi everyone. The design methods for improving tension ability is the function of an electric power system is to convert energy from one of the naturally available forms to electrical form and to transport it to points of consumption. Then a properly designed and operated power system should meet the following fundamental requirements: improve the maximum power transfer capability. The improvement with depends adequate spinning reserve must be present to meet the active and reactive power demand. Then minimum cost with minimum ecological impact. Third one is the power quality must have certain minimum standards within the tolerance or limit, such as implement and use higher system voltage level, install additional transmission lines, install lines and transformer with smaller reactance value, then install series capacitive transmission line compensation to reduce the overall reactance of lines. Then install static VR compensator and flexible AC transmission system, that mean called FACTS. If the power quality must have certain minimum standards within the tolerance or limits, such as constancy of frequency, constancy of voltage, level of reliability. It has some implementation or remaining that are high speed fault clearing, high speed recloser of circuit breaker, single pole switching, use generators with larger machine inertia and with lowest transient reactance. Uh, then the use fast responding high gain exciter, or the effect is to increase the generator output during the fault and post fault periods. Critically clearing times are increased. The factors affecting power qualities are switching surges, lightning, flickering of voltage, load shedding, electromagnetic interference, line capacitance and line inductance, operation of heavy equipment. So the mainly it involved in a power operation control, plant level control or generating unit control, system generation control, transmission control. That implementation including fast valving. The fast valving acts to balance the mechanical and electrical powers. This provides reduced acceleration and longer critical clearing times. So it just braking resistor in power system area of generation can be temporarily separated from the load areas. When the separation occurs, the braking resistor can be inserted into the generation area for a second or two in order to slow the acceleration. This is reduce complexity of the transient stability analysis, simplifying assumption are made. So the governor control or prime mover controls are concerned with the speed regulation of the governor and the control of energy supply system variables such as boiler pressure, temperature and flows. If the speed regulation is concerned with the steam input to the turbine. So each synchronous machine is represented by the constant voltage source behind the direct access transient reactance. Then the governor action are neglected and the input power are assumed to remain constant. Using the pre-fault bus voltages, all loads are converted to equivalent admittance to ground and are assumed to remain constant. Then the damping or asynchronous powers are ignored. Mechanically, a rotor angle of some machine coincides with the angle of the voltage behind the machine reactance. Machines belonging to the same station swing together and together are represented by one equivalent machine. Then the variations in load speed of governor varies as the load is inversely proportional to speed. Finally, the speed of the generator varies and the governor senses the speed and gives a command signal so that the steam input of the turbine is changed relative to the load requirement. Thank you.